Hello everybody. So today we're going to be talking about empirical formulas. So I want to start you off with a definition really quick. The empirical formula is the simplest formula of a compound that agrees with the elemental analysis. It shows the lowest whole number of moles and gives the relative number of atoms of each element present. So for an example, right, the empirical formula of hydrogen peroxide is HO. But the molecular formula rather, and I'm gonna read off the definition of the molecular formula right now. The molecular formula shows the actual number of atoms of each element in a molecule of a compound, right? So in reality, hydrogen peroxide is H2O2. But we simplify it to the base level. That's why the empirical formula is HO. So now I want us to tackle an empirical formula example problem. So it says a sample of a sample of an unknown compound contains 0.21 moles of zinc, 0.14 moles of phosphorus, and 0.56 moles of oxygen. So find the empirical formula. So I want you to write, first of all, what we're going to call a pseudo formula. And a pseudo formula looks like this. It's not, so pseudo means like fake, right? So our pseudo formula is going to be, it said zinc, phosphorus, and oxygen. So this is what our empirical formula looks like. What we're gonna do now, okay, so basically it said there's 0.21 moles of zinc, 0.14 moles of phosphorus, and 0.56 moles of oxygen. So that's why we're writing it like this. This isn't the empirical formula. This is the pseudo formula that we're gonna have. So the empirical formula is, we want to simplify this in a way. So that we don't have all these 0. Whatever, right? So now what we're gonna do is, I want us to divide everything. So one of these is gonna be the smallest. They're normally not all the same, otherwise you'd low-key know the empirical formula already, right? So I'm gonna divide by the smallest number that is present, right? So I have this divided by 0.14 divided by 0.14. And now, because like, why did I divide by 0.14? It's the smallest out of all of the numbers that I have, right? So I'm gonna end up with this. This is 1.5. This is 1. This is 4, I believe. Oops. Yes. So this is what we now have, right? And now what I want to do, let me make sure I get this correct. We want these, so we still, this is close, but we still have like a decimal here. And we want everything to be whole numbers because we want the lowest number of the lowest amount that we can get in terms of whole numbers. So I'm gonna multiply everything here by the amount that's gonna give everything that I have a decimal in, the whole number, the smallest whole number. So that'd be this. I want to multiply everything by 2 because that's the smallest amount I can multiply it by to get a whole number, right? So I'm going to go ahead and multiply everything here by 2. I'll write this in red. So this, I'm multiplying by the smallest integer that gives whole numbers. Let me put it like that, okay? So I'm going to multiply this by 2, multiply this by 2, multiply this by 2. And that's going to give me bam. That's my final. Let me just double check myself. Yes. This is the final answer. So that's the empirical formula for this compound that they've given us. So what you're going to want to do first is write out your pseudo formula, right? When they say 0.21 moles of whatever, you write that in, right? then you're gonna divide by the smallest number, okay? The smallest number that you have out of these, right? So once you divide that, you get something that looks like this, but you might still have decimals, right, by the end of it. So you're gonna multiply by the smallest integer that gives whole numbers, which in this case happen to be 2, okay? So try out your own empirical formula, take a stab at some problems, and let's keep learning chemistry, okay? If anything was unclear, please don't forget to comment in the comment section, and please don't forget to like and subscribe. Thank you.